right now. That's our toy. Okay, well, let's look back at yesterday, and this is what we're going to be dealing with today. Essentially, we're looking at estimating the mean from a population. So there's something in a population that you want to know: their average weight, their average IQ, their average wealth, whatever it might be. The thing that you're trying to find is a mean, right? So means can be any number, right? You could be an average height, 62 inches. You could be an average weight of 190 pounds. So it's a little bit different from proportions. When you estimate a proportion, your answer is going to be typically between 0 and 1. Oh, that little girl. From 0 to 1, or maybe 0 to 100%. But when it's mean, that's different. So here is a rough guide to how you should approach that, collecting and using this information. Was the data unbiased? That's a pretty biggie. So make sure that you asked a good random sample of people. Make sure that you asked it in a way that was unbiased. Make sure that you got enough responses from the people and that you're pretty comfortable that they told the truth. So that and others. So you need good data to start with. That's pretty much true for everything. Now this one is a bit vaguer. Is the sample large enough? When we did proportions, there was actually a test. And the test basically said that that guy should be at least 10 and that guy should be at least 10. It's called the 10 rule. Basically, that means at least 10 people should say yes to your question, and at least 10 people should say no. There isn't such a clear-cut decision about how large a sample is. It's mostly because there's so many different types of data. Some data are very normal, very symmetric, in which case very small sample sizes can still give you good results. And other data is like double bumps and skewed to the left. And in those situations, you need a lot more numbers before you can be comfortable you're coming up with the data. So this is not a hard and fast rule, but run about a sample size of 30 is reasonably safe in every situation. Now, does that mean that they sometimes do samples with 10 people? Definitely. Seen it done. Can you do it with more than 30? Please, if you can, always do it more, right? But, so that is not a hard, rule like this is. You might go to another textbook and they say it has to be 50 or it has to be 20 or whatever the opinion of the person at the time is. So you collect your data and we will use SALT to find the confidence interval. And once you've got that interval, you then can make conclusions. So here is a pretend question to kind of set up this process. We collected a sample size of 150 people. And we gave them an IQ test. And we found that the mean IQ was 103. And the standard deviation was 1.5. And we'll assume, as you will pretty much in every question, that it was good data that I used and that my sample is big enough. I think there's a homework question where they ask if the sample is big enough and it isn't, and you say no. And then they go on and ask you to get the kind of confidence interval anyway, which is a bit stupid, but they do. So we can assume that these are true, which certainly is for that one. And there's no indication in what I said that it would be different. And so we're going to go to SALT. And let's get myself sorted out here a little bit. So nip over to SALT. There we go. and click on it. That's fine. Okay, so here is salt. Inferential statistics is what you want. So I'm going to write these things down. So that'll mean it'll be a little bit slower than usual. So you pick the top inferential statistics and that. Boom. And then you have the procedure. We're going to use in these situations the one sample t distribution, the student t distribution if you want its full title. So I'm writing that down. Under mean, you put the mean of our sample, which is 103. Under standard deviation, you put, in our example, it was 1.5. And then on sample size, you put, in this case, 150. So I have the mean, there's my standard deviation, and there's my sample. And then you scroll down here and you click that little guy. And the guy that you pick is the confidence interval for mu. Mu is the population mean. So this is the confidence interval for the population mean. And then you choose your confidence interval. Let's assume that it's 95, because almost every question is. I'll write that down. And then you hit generate results. Writing that down. And everything that you need to know is here. So we know that the sample was 150. We know that mean, and we know that standard deviation, because we already knew that anyway. There's the standard error. There's a thing called the degrees of freedom. And the guy we're interested in are these last two numbers, because they are in fact the interval. So our 95% confidence interval in this question is 102.8 if you round it off to one decimal place, and it's 103.2. And that's pretty much every situation is going to look like that one. Now, let's kick back in. There you go. So we're number 3, collect the data, or insert it in this case. Use salt to find the confidence interval. So this was all the buttons I pressed, kind of just written down, in case you wanted to kind of go to little cheat sheet for how you would do it. And based on this 150 people with an average IQ of the sample of 103 and this standard deviation, we can make the assumption, or conclusion is a better word, that the IQ, the mean IQ of the entire population, is somewhere between 102.8 and 103.2. Okay. And then you have conclusions. Sometimes they ask you, is there enough evidence to prove something? And other times you just write down a sentence describing what you said. So suppose I went in, suppose this was a question. Is there enough evidence to prove, statistically prove, that the mean of the population I guess I should call it the mean IQ of the population, is more than 100. Right, based on that interval that you see in front of you, that we're 95% sure that the correct answer is probably going to be somewhere in that region. Is there enough evidence looking at that interval to say, yes, that is reasonable to conclude? That's my question. Is there enough evidence? You may have to hit the space bar to talk. Now, I could tell you, but I don't really want to. It's much better if you figure it out. It's kind of obvious.
Yeah, there's enough evidence.
Yeah, kind of obvious, right? In your own words, the answer is yes, there is. Why?
Because both of the limits are above 100.
Yeah. Isn't everybody in that interval more than 100? That's all it is. So pretend that we did a totally different question and the IQ ended up being 95.1 to 99.2. Maybe we got the IQ of 150 football players and that was their average IQ. Would we be able to, using that interval, say that the average IQ of football players is less than 100? Is there enough evidence to say that it's less than 100? Great. How do we know? If every number in the interval is less than 100, that's evidence that the average IQ, right, is somewhere less than 100. If you got an interval, and let's say it was 97.1 all the way up to 102.3, let's suppose that was the IQ interval. And I said, is there enough evidence to show that the average IQ is greater than 100? The answer would be no. Because some of these answers are less than 100 and some of these are more. So if it contains 100, then you will always answer with not enough evidence. It doesn't mean yes, it doesn't mean no. It means there's just not enough evidence, right? I don't know if you committed the crime. I don't know if you didn't commit the crime, right? There's just not enough evidence for me to make that decision yet. Now, when you did proportions, so let's talk about proportions for a minute, a very similar thing would happen. You could get a proportion that had numbers like that. You could get an interval that had numbers like that, or you could have an interval with numbers like that. And if your confidence interval looked like this, or looked like this, or looked like this, couldn't we make assumptions based on that? This would be from the difference. This would be P1 less than P2. So the population proportion of the first one is less than the second. This one would be inconclusive. And this one would be P1 greater than P2. That's what we would get if we were looking at the difference between two proportions. And lastly, you could get guys like this when you look at the single proportion questions. So you collect the data on just one sample or one population, and you might get numbers like 0.21 to 0.3, 0.31, 51.6.8. And actually, you only really need to do one of these guys because they can all be used the same way. In this case here, couldn't you say there's evidence that it's this one there? It's more than 0.2. If I use this one, I could say that there's evidence that it's less than 0.6. If I wanted to use this one, I could say there's evidence that it's more than 0.5. As long as everybody in the interval is what you are trying to show here, then you've got evidence. And in fact, isn't this interval here evidence that the proportion is bigger than 10%? 12%, 18%, I guess technically 20.9999%, if I was really cutting it. But there's also evidence that it's less than 50%, less than 40%, less than 38.1%. So when you're looking at these single intervals, these single means, you get information about the value of the mean or the value of the proportion. And that was kind of what I wanted you to get from that. Any questions before we try another one? Okay. We're going to do another question where all the information is given. And then we're going to go and we're going to do a question where you're just going to deal with the raw data. In other words, the 10, 20 numbers, whatever it might be. So who shall we pick this time? Okay. So we got this population and it's got a small sample, 30. And the mean ages of everybody was 25.1. And the standard deviation was 5.9. So we got a class of 30 students. We're using that as our sample to represent the whole college. And the average of the students was 25.1, and the standard deviation was 5.9. Now, I could have done that with this class, but it would have taken a fair chunk of time, wouldn't it, to get all your ages and then go into my calculator and figure out the standard deviation and mean, and 10 minutes later we've got it. So let's just pretend that's our class, right? And our class is being used to represent Olympic College students. And I think that's pretty reasonable. I don't think you're anything different from a typical student. And so how will we get this one? Well, this time I want to find a 90% confidence interval. Let's see how that works out. Right, I've got all the numbers I need. Got them written down here. I'll go over here. I'll use this one because it's already set up. So inferential statistics, one sample. The mean is 25.1 now. That's how the year, average age. So 5.9, and the sample size is 30. There's my confidence interval. But I want 90, and I generate results. And the interval that I got is here. So it's about 23.3 to 26.9 to 1 decimal place. If you've got all the data, right, less than a minute to get the answer, right? Salt does all the heavy lifting for us. Well, let's look at that interval and see what kind of conclusions you might come up with. So a 90% confidence interval for the average age of OC students is 23.3 to 26.9. Would it be reasonable for me to say, as a conclusion, that the average age of OC students, right, all of you, is more than 23 years old. Agree? How do I know that? Isn't every single number in that interval bigger than 23? I could say the average age of OC students is less than 27. Sure, everybody in that interval is less than 27. I might say the average age of OC students is more than 25. But if I said that one, I'd be pushing my luck. In fact, there's not enough evidence here to prove that. Well, you might say, well, 25 is there, which I agree, and so's numbers bigger than it, but aren't there numbers less than 25 in this interval? So you cannot say that last statement. You can't say, yep, we've proved that the average age of an OC student is more than 25, because every single number in that interval is just as likely to be the population mean as any other number. So couldn't it be 24, for example? 23.7, could be any of those numbers. And none of those ones I just mentioned are more than 25. Are we good? So, the second kind of way that you get your data, I've got the question down in front of me, if I show it, is when you don't have the mean and standard deviation given to you on a plate. You get the data more realistically, don't you get the data like that? And you are going to take that data and you are going to, not surprisingly, calculate a 95% confidence interval, because this book doesn't know there's a 90 and a 99. It does them occasionally, but not very often. So how is SALT going to help us? Well, if SALT button wasn't there, wouldn't I have to find the mean and standard deviation of that data? Now, could I do it? Sure. If you look back at week 2, I think it was, we showed you how you can do it on your calculator. But I prefer not doing it because it takes a lot of time. And I'm going to hit use SALT button. And the data, there we go. The data is already here. Do you see it? And if you were actually physically doing this, you might use this one and then just change these numbers into our numbers, right? So that's kind of how it does it. And then I'm going to go over to inferential statistics. And it's already set up. See that? One sample T. Number, oh, I should tell you the story. The latest antidepressant produced is currently involved in a testing process. 8 subjects have joined the testing process where the mean number of days taken before side effects disappear is being examined. Right. So that person, 5 days, the side effects had gone and it starts doing good stuff. This one. Antidepressants are very strong drugs. I mean, they affect the body, the brain chemistry. And so it's pretty typical for almost all drugs that deal with psychological problems to have side effects. Never taken any, but if I needed to, I certainly would. Some of the side effects are loss of appetite, insomnia, tiredness. I mean, things that you can imagine, you know, things that when your brain is affected tend to affect motivation in various ways, or appetite, or, you know, energy levels and so on. So that's not a bad thing. One of the bad things about, I just don't know if it's a good word to use, but anyway, one of the bad things about people who are being treated with drugs for mental issues, mental problems, is that as long as they stay on the drugs, they're actually going to be very successful in many cases. But if you know right now on the streets in some of the major cities, there's a large number of people who are on the streets, right? The homeless, and a great number of them have mental issues, and they're not taking their drugs, and that tends to make them less social, and they do things that they certainly shouldn't. One of the really weird ones, unfortunately, is that there's certain forms of manic depression where you believe there's nothing wrong with you. It's the world that's wrong. Now, while you're on your drugs, you think normally, and you think, yeah, it's just that's not reality. But the minute they go off the drugs, they think, I don't need the drugs anymore. I'm okay. The minute they go off the drugs, they get that, manic way of looking at the universe, and those types of people can be very dangerous, unfortunately. Anyway, back to this fella. There's the data, there's the mean, there's the standard deviation, and there's the sample size, right? All done for us. I just need to click on that and do, I think it was 95, generate the results. And the answer is somewhere between 13.8 and up to 26.4 days. So let's click out of that for a minute. So if the data is given to you as a list of numbers, don't you just hit salt, and then you have to move over to the inferential statistics, and everything is pretty much transferred directly to you. If sometimes it's not, just write down what the mean and standard deviation is and then transfer it. And in this case, we got that data. So that sample size was ridiculous. It was 8 people. And if they were being honest, shouldn't they have said, don't do this? The 8 breaks. Doesn't it break? Rule number 2. Is the sample large enough? Would you want to bet anything on 8 people? No matter what it was, height, weight, whatever. Yet it was done, and we'll assume then that the data was nice and normal, so maybe that's the argument they got away from, they got away with it. It's a huge spread of values, isn't it? If I was going to make conclusions, I would say the average number of days that you're going to have side effects when you're on these drugs is more than 13 days. And it's going to be less than 27 days. So if I was being really rough, somewhere between 2 and 4 weeks is what the going rate for most people would be. So if the doctor was prescribing the drugs, he says, look, different people, different side effects. You might lose your appetite, you might not sleep so well, but it's not going to last forever. Typically 2 to 4 weeks and you're fine, right? You'll be able to, get on with your life and you'll be fine. And it's important to note that. Suppose someone took 39 days and they were still having side effects. If you were the doctor, would you probably think that's not good? I think I'll find a different medication for you, right? This one ain't doing it. You can't live your life with side effects. That's almost as bad as trying to live your life without any treatment, right? So it gives doctors a kind of window of, yeah, this is normal, don't worry about it. But if it's abnormal, like extra long, come in, we'll find another one. There's many different treatments, and some people's body chemistries, brain chemistries don't react well to certain drugs. Okay, we need a pleasant one to do here. So what one will I make up? Right. Who should I pick? Okay. I have told jokes for 100 days. Pretend. And the average number of days that people thought they were funny was 17 days. And the standard deviation was 5. And I would like to do a 99% confidence interval based on what is the average number of days that people would think my jokes were funny. So you can imagine what that would be. So I asked Mark and he was an 82. And I asked Ian and he'd say, I seen that one coming. So he only said it twice. And Krista says, you're just not funny. So she said 0 and so on and so forth, right? So the numbers are spread out all over the place. So I should be able to just jump right over to this fella here and put the information in. So here we go. Don't worry what this is called. I'm just using this as a template. So I can go over here and I can put in that it was 17 and that the standard deviation was 5 and the sample size was 100. And I was looking for a 90% confidence interval. And I generated the result and it came out as somewhere between 16.1 and 17.8. So in that 100-day period where I was telling jokes, the average number of days in which I told the joke that was funny was somewhere between 16 and 18, if you round them off very roughly. So at least it's more than 16 days, isn't it? But it is less than 18. So I could have said that as well. So I'm going to try for a joke, right? Now, what shall I pick? Have I done Chuck Norris jokes? Ah, okay. I didn't know Chuck Norris jokes until I came to America. So I'll tell you my Chuck Norris joke. If you're not aware of them, I assume you are. The idea, to me, the idea of a Chuck Norris joke is that Chuck Norris is bigger than life, right? He does things that are impossible, right? He's just bigger, stronger, cleverer, you name it, right? That's the theme behind it. So, do you know Chuck Norris doesn't read a book? He just stares at it until it tells him what he wants to know. Chuck Norris does not do push-ups. He pushes the earth down. Chuck Norris doesn't believe in the periodic table. The only element he believes in is surprise. Chuck Norris's tears cure cancer, but they haven't been able to prove it yet because he doesn't cry. Okay, Krista, have you got a Chuck Norris joke to add to my list? No. Okay. Anybody got a Chuck Norris joke to add to my list?
Sure.
Go. What you got, Brady?
Chuck Norris has a bear rug in his room. The bear's not dead, it's just too afraid to move.
Good. Anybody else?
Yeah. While hiking through the desert, Chuck Norris got bit by a cobra. And after 3 days of excruciating pain crawling through the desert, the cobra died.
God, they're bad. Chuck Norris has counted to infinity. Chuck Norris has read the internet. Any more?
I feel like I haven't heard a Chuck Norris joke since about 2010 or so.
See, give you an idea where my material is coming from now. Okay, let's finish with one joke because this is a good point for us to finish anyway. We're well ahead of the schedule. Before I do that, let me remind you all the good stuff in case I forget. Make sure you put your name down for attendance. Your online test will be available sometime later today, probably about 1 o'clock. And everything, including your homework, will be due on Monday because Monday is a holiday. So I will not see you until Tuesday. Okay, I think that's all.